Okay, I hope you are good to go, isn't it? My screen is visible. Are we good to go? Come on, everyone. Okay, then. So, we are discussing about what the Java 8 futures and what are the things that we have discussed so far. So, we have discussed what is Lambda expression. So, it's very easy to answer, isn't it? Lambda expression. Lambda expression is what? Anonymous function. So, and again, what is an anonymous function? The anonymous function is a nameless function, right? So nameless, as well as you don't have any name and you don't have any modifier, you don't have any return type. Okay, and if you design such function, it is called as autonomous function, right? And it was introduced in the year, it was introduced in JDK 1.8 since Java 8 futures, right? So it is JDK 1.8. So there is no explanation required for this. And these are the benefits of Lambda expression, and we have also discussed about the syntax. So this is how the Lambda expression syntax looks like, right? This arrow token is very important, or arrow operator. Okay, parameters followed by the block of the Lambda expression. So they are separated by what? The arrow token. So we have completed so many problems on top of Lambda expressions, right? And to invoke Lambda expression, you can write a Lambda expression, but in order to invoke Lambda expression, you use functional interfaces. And again, what is functional interfaces? Just remember this word SAM. SAM, SAM. So SAM is an acronym for single abstract method, right? And you have already answered the question for functional interface. Any interface that has single abstract method is called as functional interface. That's it. What are the examples? In the Java library, you have what? The runnable interface, callable interface, comparable interface, and you also have comparator. Comparator is also an interface which we have discussed in the collection framework, which has a method called compare method. Right? These are the abstract methods. Only one abstract method you have inside this particular interfaces. Right? So what is the purpose of function interface? To invoke Lambda expressions to achieve backward compatibility. So this is the typical syntax of functional interfaces. Right? And also we have discussed about how to invoke Lambda expression using functional interface. Okay. Today we will start discussing about Lambda expressions with respect to what? Lambda expressions with respect to collections. Okay. Already we have completed discussing about each and every collection topic in detail. So how we can apply the Lambda expression with the collection framework. Okay. Again, those who again I'm going to give you the few briefing about the collection framework. Okay. So what is collection? When I ask you what is collection, okay, my question is what is a collection? What is a collection in Java? Right? So if you want to answer this, answer is very simple, guys. If you want to represent a group of object as a single entity, so Java is an object-oriented language. We know that already. Okay, everything in Java is an object. Java is what? An object-oriented programming language. You create number of objects. Okay, you create number of objects. For example, let's say that you have created this many objects, right? If you want to represent all these objects, if you want to represent all these objects as a single entity, you want to represent all these objects inside a single entity, right? If you want to store all the individual objects as a group, as a collectively into a single entity, right? Then you can use what? You can use collections. Anything, for example, if you want to take the real-time example, okay, the collection of pens, collection of pens. So the name itself has the meaning. The collection of books, or the collection of what we call it as anything, collection of students, right? Or else collection of movies. So you can, in the real-time example, everything can be represented in a collection. So even in Java, when you specifically talk about the collection is representing what? You want to represent a group of objects as a single entity. Can I say that? What is a collection? What is a collection? What is a collection in Java? A group of objects getting represented as a single entity. It's called as what? Collection. Right? So likewise, so in the real-time example, even the collection framework has been divided into many parts. We know this all. We know this already. So there is what? There is the list interface. There is the set interface, right? And there is the map interface. So it has been divided into so many parts because you have to manipulate with the objects in such a way that each and every time you are going to have a new requirement. So when I say new requirement, if you want to deal with a group of objects where you want to follow what? Insertion order. If you want to deal with group of objects where you want to follow insertion order, and where you want to preserve, where you want to keep duplicates. If you have this kind of requirements, then you can go for list. Right? Likewise, if you have a different requirement, okay, if you have another requirement like where you want to eliminate duplicates, where you will not give importance to the insertion order, but you don't want to add any duplicates, right? So when you don't want any duplicates, so you usually do what? You choose set. Right, and you have another requirement like you want to represent group of object in the form of key value pair. Is also a requirement, right? So every data will have its own requirement. So you cannot just say that my data or my object has to be when I add an object, I want my object to be inserted. The insertion order of the object to be preserved, or I want to keep duplicates also. That there could be many number of requirements for your for your requirements, right? There can be many number of requirements in the real life, right? So based upon the requirement, you are going to choose the respective collection sets. Like you have list, you have set, and you have map. Likewise, even if you want to store the objects in the form of key value, for example, I have a student name or else a student roll number, and key is student roll number and the value is student name. Right? If you have a requirement like I want to store the data in the form of key value pair, so two objects, there are two objects, and these two objects should be represented in the form of key value pair. What is an example? Roll number and the student name. If you have this kind of requirement, you can go for map. Right? So what did I just say? Even in the list, okay, when you choose a list in the collection framework, list has many classes. Right? You can choose what? ArrayList, and you can choose either linked list, and you can choose vector, or you can choose stack. These are the options that you have when you are choosing the list interface. This many options are there. Right? Likewise, you have an option to choose the set interface. Okay, this is set interface. So again, in the set, there are many options. There are many multiple options are there. So these are the options based upon the requirements. You can choose whatever the options that you like. You have hash set, you have linked hash set, okay, and you have tree set, right? And you have sorted set, navigable set. So many options are available, but I am just going to talk about the collection framework with respect to Lambda expressions. So we are not going to deal much with these concepts. So just for the basic understanding, just to give you the background once again, so that you can understand lambda expressions really well. So in the map also you have options like hash map, linked hash map, etc. Linked hash map, etc. Right? So my requirements, I have a collection of objects. So I want to I want to add, I want to take collection of objects into a single entity. Okay. My requirement is I want to ensure that the insertion order is preserved and it is allowing duplicates. If that is my requirement, I can choose list. I can choose list. Right? If my requirement is I want to ensure that if the I do not want to worry about the insertion order, but I want to remove duplicates, then I can go for set. If my requirement is I want to represent data in the form of key value pair, then I can go for map. But based upon the requirement, I have an option to choose between list, set, and the map. Right? So what is you just remember these keywords. So list means insertion order, duplicates are allowed. Okay. Set means duplicates are not allowed. Okay. And map means if you want to represent data in the form of key value pair. Specifically, okay, key is an object, value is also an object, but for the keys duplicates are not allowed. Allowed for the keys. Okay, this is the core idea about list, set, and map. Why we are discussing all this? To invoke, we are discussing all these things to apply lambda expressions on the collection framework. Okay, this is a basic idea. We have discussed these things already for almost 1 month. Okay, this is just a background. Okay, now I want to use ArrayList, guys. I want to use what? I want to use ArrayList. ArrayList integer. Okay, if you see just a small piece of background I'm giving you, or let me take it as ArrayList string. Okay, string is a generic type, and I want to add some names. Names equal to new. Okay, string is the generic type. Okay, let me add quickly 4 names. Names dot add. Okay, so I want to add 4 names like let me add actress name, popular actress name Vijay, Ajit. Okay, and we have Surya. Okay, we also have what? Vikram. Okay, popular actress in the Tamil film industry. Okay, now I want to do what? If I give system.out.println, if I try to print the reference variable, okay, so the purpose of ArrayList is it is going to preserve the insertion order, and also it will what? If I try to add Surya for the second time, okay, look at the output. Look at the functionality of ArrayList. So ArrayList is trying to do what? Trying to preserve the insertion order. Okay, so the elements are added in one order. The same order is preserved, right? So Vijay is added first, followed by Ajit, Surya, Vikram, and again Surya. So duplicate elements are also considered for the ArrayList. Duplicate elements are also considered for the ArrayList. Okay, if I convert the ArrayList to as set, to convert the ArrayList to what? As set. Okay, so this is the answer for ArrayList. Let me copy it and let me paste it here. You will understand why we are discussing these things once again. Okay. This is how the array list is going to preserve the insertion order, right? And array list will also allow what? I mean, not array list, the list. I'm talking about the complete list, the property of complete list. Okay. The complete list is going to allow duplicates as well. Insertion order is preserved, duplicates are also allowed. If I convert this to as set, if I run this code, okay. So as set will never talk about insertion order. Insertion order will not be preserved because internally it is using hashing mechanism. We have discussed these things already. But duplicates are also eliminated. Surya is added for the second time, but only one Surya is considered. There is no second Surya here. Isn't it? So by this I can conclude that the set is not allowing duplicates. So likewise we have a map also. Map is going to always talk about what? The key value pair. Okay, this is the complete background about the Java collections. And now if I want to use the Lambda expressions with respect to Java collection, how I can do that? Right? The same example I'm taking, guys, focus here. The actual class starts from here. The same example I'm taking, but this time I want to do what? I want to take the array list. Instead of names, I want to take numbers. Instead of names, I want to take numbers. And the generic type that I am passing it here is what? Integer. Generic type is being passed as integer. Okay. Now you see, I want to add few numbers. Instead of names, I want to add few numbers. 100 I want to add. I want to add something like 10. I want to add something like 5. I want to add something like 200 here. Okay. I want to add something like 4. Okay. So let me replace the names with numbers. Okay. If I run this code, it is going to preserve the insertion order. So this is how the output is going to look like. There is a method, there is a method called sort method in the collections. So if I use that method, top of collections class, okay, and if I pass the reference variable of array list numbers, okay. So what it is going to do, internally it has some logic. That logic is going to give an output in the form of ascending order. All the elements, all the objects will be sorted in the form of ascending order. See, before sorting, the insertion order is preserved, and you are applying sort method. You are using sort method, and you are passing the reference variable of array list. All the elements, all the objects are sorted in the ascending order. Right now, the question is, so this sorting is, it is following the natural sorting order. It is actually following the natural sorting order. So what is the natural sorting order? For a numbers, the natural sorting order is ascending. Okay. For strings, the natural sorting order is what? Alphabetical order. Okay. So if you look at this, so it is not giving you an option. Okay. So it is always following the natural sorting order. What if you want to customize this? You want to customize this order. Customization means you do not want to get the output in the form of ascending order. Instead, you want to get the output in the form of descending order. Focus here. Descending. I want to get the output in the form of descending order, but it is giving me the output in the form of ascending order. Okay. We know that already. To customize the sorting order, we have to use an interface called comparator interface. If you remember or not, I don't know. So we have discussed about this comparator interface in the comparator interface. What is the purpose of comparator interface? It is used to define your own sorting order. Okay, so there is one abstract method inside the comparator interface. I can write many points on top of comparator interface. Comparator interface, it is a functional interface. Functional interface. Second thing is it has only one abstract method called compare method. Okay. What is a prototype of compare method? Public integer compare. So this compare method is going to accept two objects, object O1 comma object O2, and the return type is integer. Any integer you can return. So if you look at this comparator interface, ideally this comparator interface, it is used to define your own sorting order. First point, it is a functional interface, right? This I focus on this point. It is a functional interface, right? And it has function. Any functional interface can have only one abstract method, and inside this comparator interface, you have a method called compare method, right? And this is the prototype of what? Compare method. Right, now go back to our theory. So we have invoked lambda expressions. So far we have invoked lambda expressions by using the user defined interfaces, right? So to invoke lambda expression we use functional interfaces. Till yesterday we have invoked lambda expressions using functional interfaces of user defined. Now from today we are going to invoke lambda expression. To invoke lambda expression, we use functional interface of predefined. So don't you think that this comparator is a predefined interface? So I can use this interface to invoke my lambda expression. Right? How is it really possible? We will understand that. Okay, this is the agenda. This comparator interface is used to customize your sorting. First of all, you can customize your sorting because ideally when you see that I have an option to sort my objects in the natural sorting order, but I want to get the output in a different sorted order. So different means what? Descending order. I want to get the output in the form of descending order. How I can get that? I can use comparator interface, right? So what are the things that we have in the comparator interface? You have the compare method, and it is a functional interface. When something is a functional interface, just blindly think that, oh, this is a functional interface. This can be utilized for, this can be used to invoke lambda expressions. You can blindly think that. Functional means lambda. Lambda means functional. Okay. Always ensure that these two concepts are going together. Okay. Functional means lambda, lambda means functional. How I can? First, I need to write a program to do what? I need to write program without using lambda expressions to define my own customized sorting order using comparator. Okay. First, we will try to write a program by to define our own customized sorting order by using comparator. Then we will talk about how to use this by using lambda expression. Now we will talk about without using lambda expression, how does the code looks like. Then after getting some background, then we can directly convert the expression into a lambda expression so that you will get the complete picture. Okay, so I want to give you some more insights here. For example, if I want to compare two objects, guys, I have two objects. For example, let me say that I have an object like 10 and I have an object like 20. Focus here. I have two objects 10 and 20. I want to compare. Okay, I want to compare. So what I am doing it here, blindly I am going to do what? Blindly I am going to find the differences. I am going to use a signature called minus, or I am going to use what? The operator called minus operator. I just want to find the differences. So this is my first object, this is my second object, right? If my output is, if I do subtraction, if I get output and if the signature of the output is negative, so what is the mathematical answer that I am going to get when I do subtraction. 10 minus 20 is going to give me it is not going to give me 10. So difference is 10, but the mathematical answer is going to be what? When you apply max on this, the answer is going to be what? Minus 10, right? 10 minus 20 is going to give minus 10. Okay. Now I want to do what? Secondly, I want to do like 40 minus 20, something like this. Okay, what it is going to give me? So literally plus 20, right? And the third one is 10 minus 10. What is the answer that I am going to get? Okay, 0. Okay, so this is a simple calculation where it is going to help us to understand about the internal working of compare method. Okay, so can I conclude that, guys? Can I conclude that? See, this is my first number. I am passing the first number as 10. I am passing the second number as 20. Right? If my output is negative, forget about the answer. If the output is within the negative signature, so output I am getting minus 10. If it is negative, can I conclude that the second number is larger? Not only in this example, in any example, if you take two numbers, okay, if I am giving you two numbers, hey, please take 200 and please take 400. First number is 200, second number is 400. Right? How we can conclude that which number? We know by looking at this, we know that yes, 400 is bigger. How Java knows? So if Ratna is seeing these two numbers, if I ask Ratna 200 is bigger or 400 is bigger, Ratna is going to say 400 is bigger, because we are capable to define answer the things just by visualizing it, isn't it? How Java knows? Java will use minus operator, and Java will say if the output is negative, minus 200. If I do subtraction, definitely it is going to be minus 200. With the signature, it can say if it is a minus, if the signature is coming as minus after a calculation, then it can conclude that the second number. For Java, it is always about the first number and the second number. It's always about what? The first number and the second number, isn't it? Okay. This is first number, this is second number. This is for Java. Always talk of it's always considered first number and second number, and if the output is negative on subtraction, then it will say second number is larger, or it can say first number is smaller, right? And like that for Java. And if you're passing two here, see, if you're passing two different set of numbers, if you're asking Java, hey Java, first number is 40, second number is 20, which number is bigger? Right? So based upon the output is 20, forget about the number, see the signature, plus 20. So plus means first number is bigger. Okay, plus means always the first number is bigger. If the output is coming as negative, means always the second number is bigger. Again I am asking, hey Java, I am giving you two numbers, 10 and 10, which number is bigger? Okay, it is getting output as 0. Output as 0 means, oh, Java will think, okay, output is coming as 0. It means both number must be same. Both number must be same. Yes or no? And look at the signature. So if you see, this is the first number. This is the first object. You are passing first object as 10, and you are passing second object as 20. Second object as what? 20. Okay, and if you look at this, if you look at this exclusively, if you keep brackets and if you keep a comma, okay, this is a natural sorting order, isn't it? First number followed by second number. The first number is smaller, second number is larger, which means ascending order. Okay, internally, the compare method as such a design that it will recognize the order. I mean, it will create the ascending order based upon the output that is going to get, based upon the signature it is going to get. If it is minus, ascending, right? And if it is plus, then if you see, and if you look at this order, right, first number is 40, first object is 40, okay, second object is 20. isn't it? And if you focus the order here, if you just focus the order here, okay, 40 followed by 20. Okay, so this is descending order, right? So the objects will be manipulated in such a way based upon the signature by the compare method. So that's why the prototype of the compare method is what? Public in compare method. Okay, it will accept two objects, object o1 comma object o2. So how the natural order is getting followed inside the compare method? Okay, you pass two objects, object one, object two. Every time you pass two objects, and it is going to check if o1 object 1 is lesser than object 2, o2. If object 1 is lesser than object 2. Okay, take the same example. Let us say that 10 is the object 1, 20 is the object 2. Or take the same example, 10 is the object 1 and 20 is the object 2. Okay, so if object 1 is lesser than object 2, right, what is the output that it should get? If it has to follow this order, what is output that it has to get? Negative. The signature has to be negative. So internally it is designed in such a way that it is going to return -1. So it's not like -10, -20, -100. You will get any numbers, you will get big numbers. Ideally signature matters. Ideally the signature matters. So you are returning something of negative type, that's it. You can return any number negative. So based upon the return, it will understand that, oh, we are trying. So if it is one, if -1 is getting returned, it is going to maintain the ascending order. Okay, and likewise, this is next condition, else if. What if the first object is greater than second object? Okay, return one, positive one. Okay, and last one, else. What if both objects are equal? What if both objects are equal? Return 0. Okay, this is just the intuition. I am taking two numbers, and based upon the output, I can guess that the second number is larger or the first number is larger or both numbers are same. Same thing, I am using it here. Same concept is being used in the compare method, so that by default it is going to follow what? The natural sorting order. So it will do manipulation in such a way, it will collect two objects and it will arrange everything in the form of the sorted order, which is what? Ascending order, increasing order. Right? So let us understand this practically with a small piece of code. Okay. So see, so driver. So we are dealing with the functional interface. So there is a method called there is an interface called comparator. A comparator is an interface. It is inside the java.util package. So this driver class is implements comparator. Okay, it is expecting a generic type. So you have to pass what you're dealing with numbers here, right? You're dealing with numbers. So the generic type has to be what? Integer here, right? So once, as soon as you implement the interface, what is the contract that you have? What is your contract that you have to follow? You need to override the abstract method. So what is the abstract method that you have inside the comparator? Only one abstract method, which is what? The compare method. This is a rule, this is interface concept. Whenever a class is implementing an interface, the first contract that you need to follow is you need to override, you need to give implementation for the abstract methods. Right? Behind the scenes, internally, comparator has an abstract method called compare method. Comparator interface has an abstract method called as compare method. You are overriding them. If you are not understanding this, repeat my first two videos, you will understand this. Right? And the logic, the actual logic that is there behind the scenes. Okay, if O1 object 1 is greater than, is lesser than O2. If O1 is lesser than O2, return -1. Okay. Second one is else if O1 is greater than O2. Then one else return 0. Okay, this is the logic that anyone can give so that the output, okay, each and every object will be compared internally and the output will be in the form of natural sorting order, which is ascending order. This is what ascending order, right? So how I can utilize this compare method? So this is an abstract method. How anyone can utilize this abstract method, right? I need to create an object for this driver class. Let me remove all this. Okay. So this driver class is implementing comparator interface. Just create an object for the driver class. Driver obj equal to new driver. Okay, after creating an object for the driver class, what you have to do? And you need to use the collections dot sort method. Okay, this sort method is going to accept two parameters this time. What are the parameters? First one is the reference variable of the array list, comma, followed by the reference variable of the driver class. If you do this internally, what are the things that are going to happen? These numbers are ideally 100, 10, 5, 200, 4. You are passing all these numbers into a single object which is numbers itself. Comma, you are passing obj. Obj is what? You are creating an object reference variable for the driver class, which is implementing the comparator interface. So it has got, as soon as it implementing comparator interface, it has got all the logic for the what? All the logic for the natural sorting order. Right? All the qualities of comparator as can be given to driver class. So the major qualities are what? All the logic for the natural sorting order as also be there for this particular driver class. So you are passing the object of the reference variable of the driver class, and when you apply this, right, output will be blank because you're not displaying anything. So let me display sum.out.println numbers. See, you're getting an output in the form of sorted order. How the elements are added? In a different order, 100, 10, 5, 200. Okay, let us print this before sorting the elements. Before applying the sorting logic, if you print this, right? So before applying sorting logic, insertion order is preserved. After applying, okay, these two lines of code is written just to define the sorting order. Right? You are using the collections class followed by the sort method, and you are passing two arguments here. One of the arguments is the numbers itself. Okay, second argument is what? The reference variable of the driver. Okay, driver is just a class. What class it is? It's a class that is implementing comparator interface. Okay, all the qualities of comparator interface has come to driver class. So what is the major quality that it has? Inside it has a compare method. Okay, you have written a logic for the compare method in such a way that this is accepting two numbers every time two numbers it is accepting, and it is performing the sorting internally. Behind the scene sorting is performing sorting. Right? That's why see, if you want to imagine this further, okay, so this is how you are passing these numbers, and you are using what? Collections dot sort method, and you are passing these numbers as the first arguments, comma, you are passing the reference variable of driver class. So driver class is what? Driver class has some qualities that is adopted from the comparator. Comparator internally has compare method, which you have overridden. Okay, so this is going to internally is going to do, it is going to arrange all the elements that you have passed in the sorted order. That's it. Okay, these all the elements that is unsorted, okay, will be arranged in the form of sorted order accordingly. Every time you are passing two numbers. First you will pass 100. 100 is the first number, say followed by 10 is the second number. Right? According to sorting logic, so 10 has to come first, 100 has to come in second. Right? And why you will apply 5. According to sorting logic, this 5 will be placed here. You will apply 200. According to sorting logic, 2 will come here, and you are applying 4. according to sorting logic, 4 has to come first. So output is given in the form of sorted order. Okay. Now if you see, I have an option to manipulate this. I want to customize this. Okay, I want to customize this. So if I just change these changes, instead of -1, if I take it as +1, instead of +1, if I take it as -1. If I just change the signatures, change the signatures, and if you see the output, okay, you can customize it. So output is in the form of descending order now. Previously it was ascending, now it is descending. Right? I can also further modify this code. I can also write all these lines of code in the single line. If you remember the ternary operator, we have discussed in the core Java classes, especially about the operator called the ternary operator. Okay. So what is the syntax for the ternary operator? Ternary operator is going to have one conditional check first. Conditional check. Okay. And if the condition is true, you can return the first option, or else you can return the second option. Right? Ternary operator. We have discussed this in the core Java classes. Firstly, there will be a conditional check. If this condition is returning true, if the output is returning as true, A will be executed. For true, the first option will be executed. For the false, the second option will be executed. I can convert this to the ternary operator. How I can convert? What I am doing it here, I am doing a comparison here, isn't it? A kind of comparison. So conditional O1 is lesser than O2. Okay, condition. I am checking the condition. If O1 is lesser than 2, if it is true, okay, return 1. Else, okay, another condition I am checking. What is that condition? O1 is lesser than O2. Again, okay, again, if it is true, return -1. Else, return. Okay, I can convert all these lines of code into one piece of line by using what operator? Ternary operator. Okay, take a pen and paper and try to write this, or revise my ternary operator video once again. You will get this. These things are already discussed. So I am converting all these lines of code into one line, which is what? Ternary operator. Return first conditional check O1. Okay, if this is true, I am checking the condition. Okay, if this condition is true, return 1. Okay, else check this condition. Okay, if this condition is true, return -1. Else return 0. I have converted that all the piece of line of code in the single line. I run this code. Okay, output is in the form descending order. Say both are same, but I have converted that thing into a one piece of line, one single line of code. Both are same, I have converted. So we have written this without using lambda expression. Without using lambda expression. Now I want to use this with lambda expression. I want to convert this in the form of what? Lambda expression. Let me copy this code. Okay, focus here. Let me place it. Where is that new? I do not want to save. Okay, this is our code. How I can effectively convert these two by using the lambda expression. This is our piece of code. In the lambda expression, we know this already. Okay, there is no required to have what? Use the implements. There is no required to implement the comparator. I mean, implement any interface directly. right? What I can do directly here in the body of the statement, what I can do instead of these lines, instead of this line, okay, I can do what? I can use the driver class, driver obj equal to, let me remove these lines also, or I'm writing this piece of code here for the better understanding. So driver obj equal to, you will have to copy this method, you will have to copy the method that you are overriding. Okay. Not to exactly copying, okay. You are defining your own lambda expression. To define your own lambda expression, the access modifier is not required, return type is not required, method name is not required, right? And what are the things that is required? You need to just place an arrow operator between the parameters and the body of the lambda expression, and you need to define a semicolon here, right? How I can optimize this further? How I can optimize this further? Further optimization could be like, okay, you don't have to define the data type of the data type that you are using in the parameters. Data types are also optional. So based upon the context, compiler will recognize what data type is it, right? So what are the things that is remaining? Remaining things are what? O1 comma O2 followed by the arrow token, right? And if you see, there is only one line in the body of the lambda expression. Only one line is there. If there is only one line, this parenthesis is also optional. You can remove this parenthesis also. That is optional because you have only one line. Why you need to deal with this parenthesis? So that parenthesis is also optional. So, and return keyword is also optional. If you have only one line of code, return keyword and the parenthesis is optional. What is the code that is remaining here? This is the code that is remaining here. Okay, this is the simple lambda expression that you can use. The simple lambda expression that you can use. Okay, can we do this in the program? Okay, same thing. Okay, so the implement concept is not required. Implementing comparator is not required. Just copy this method, remove this method. Okay, directly use it in the object creation process. So this has to be not driver, guys. This has to be what? Comparator. Because you need to keep the interface name here, isn't it? And type is what? Integer. Okay, let me repeat this. So this is not driver, guys. This is comparator actually. Because lambda expression will always the type should be what? The data type should be what? The comparator type. The interface type, not driver. I missed that part. Okay. So comparator integer. So for the lambda expression, the access modifier concept is not required. The return type is not required. The name of the method is also not required, right? And you need to ensure that you are keeping an arrow operator between the parameters and the body of the lambda expression, and semicolon is also required at the end. So this is the complete lambda expression. You can go with this code, no issues. Or else you can do what I have already said, that there are some optimizations that you can do. So if you see the code, you have two parameters, and based upon the context, compiler will recognize the data types of this parameter. So this is also optional. You can remove the data types. Okay. After this, if you have only one line of code in the lambda expression, these parentheses are also optional. You can remove this parenthesis, and you can remove the return keyword also. Okay. This is the single line of lambda expression. Right? If I run this code, I have to get the same output. And again, so what you are passing here, you are passing obj. You are passing what? Obj. Right? This obj is of what type? Comparator type. Right? Instead of doing all this, you can directly pass this line of code by removing all this. Just pass the value. Just pass the value directly here. That's it. Same output error. You are customizing the sorting order by using comparator. So internally you are avoiding what? You are avoiding your class getting implemented with the comparator interface, and you are also avoiding the class getting overridden, right? And you are avoiding so many things with the help of lambda expression. This is the complete code with the lambda expression. Complete piece of code with the lambda expression. Okay, I have optimized in many ways. At last we have got this. You can also do this if you want. You can keep this. Keep what? If you want, you can keep this line of code and you can pass this reference variable here directly. This is also same as, right? You can pass value directly without even defining all this. You can just pass value all this based upon the context. Compiler recognizes that this is a complete lambda expression. No definition is required for this. You can either keep this, or if you do not want, if you want to remove one line of code here, what you can do, just copy the value, right? And you can remove this also. You can paste that value here. Both are same, right? So this is all about the lambda expression by using what? By using the concepts of collection.